Good morning. This is the next period of calculus for the people that are arriving at the Twins game, trying to get there early. What time does the Twins game start? 7 o'clock tonight? Does anybody know? No one in here knows. Well, 7 o'clock. So people are already arriving at Target Field. Probably New Yorkers. And for those people that are interested in calculus and are streaming in right now, welcome to our state. Okay, we're talking about the product rule today, all right? So let's look at these examples. Let's say I have this. I'm going to slide it over here. Let's say I tell you that f of x is equal to x plus 5, the quantity squared, and I ask you to figure out the derivative. Okay? So this is what I call, when you teach math, and especially calculus, Alexis, there are two parts. There's what I call the mechanical part. You know, it's like, how do you use a hammer? How do you use a screwdriver? How do you use a wrench? How do you use a torch? How do you use the welder? And then the creative part. How am I able to put stuff together? How am I able to solve a problem? Okay? And so I have this problem. And by the way, just to let people know out there who are following us and have figured out who their favorite student is, you know, like, who's my favorite Beatle? The Beatles were a rock band. Okay. It was George, in case you're wondering. Or, like, what's his favorite number? So I'm just, for the people that find Owen is their favorite student, Owen is now back in class. Okay, he's back from South Virginia. And if you haven't been to South Virginia, it's just south and east of West Virginia. Okay, very few people know of that state. It's our 51st state. So anyway, how would we do this problem? Or how would you do this problem? Now you have all the tools. You don't need to know anything special. Landry.
Couldn't you just put the 2 out in front, keep the x minus 5, because that's your x, because it's already in power form. So you put the 2 out in front, keep the x minus 5, and then x minus 5 to raise to the first.
It says x plus 5, right?
X plus 5.
Okay.
Raise to the first power, so then you get 2x plus 10, because you factor.
You know what? Intuitively, you're almost jumping ahead to the chain rule. Can I make one question? Can I ask you one question? In fact, I'll change this problem because I've never had anybody that had that type of insight. And you're going to be really, really happy on Wednesday. Okay? Because you're kind of there. But what would you do if I had this? Would you do it the same way? Oh, okay. What would you do?
Let's square it and then find the answer.
Okay, so can you? So could you have done that on the last one also?
Yeah, you could.
Okay. So don't forget what you told me before. Remember that on Wednesday because you'll be really close. Okay. So let's go back to your alternative way. Hey, you could do this way. Okay. But I don't want you to forget what you did, okay? All right, so you would say multiply that out or square that out. Could you tell me what that would be? And I'm going to get rid of this right here. I'm not going to take the derivative yet, so that little prime sign is gone. I want you to rewrite this by multiplying it out.
X to the 4th plus 10x squared plus 25.
Perfect. And then you said you would take the derivative of that.
Yep.
And you'd get what?
4x to the 3rd, 20x plus 1.
What's the derivative of that?
0, 0.
0. Right? You'd be done.
Yep.
Right? And it kind of makes sense. This was a quartic, and the derivative is a cubic. Right? Does that make sense to everybody that, you know, you get a polynomial less of 1 degree. All right, super. I'm going to put a sinusoidal curve right there, or waves. Okay. How would you do this? And Landry, you're not going to give me the answer because you already know how to do that. I got a feeling. Am I right? You think you know how to do that? Okay. Anybody think, now that Landry kind of did the first one, does anybody have an idea on how to do that one? Want to eventually get the derivative. Multiply it out, okay? And so you would say that's what, Alexis?
X squared plus 7x plus 1.
And then you would take the derivative and get what?
2x plus 1.
How about 2x plus 7?
Yeah, 7.
Okay. Everybody okay with that? Okay, now we're going to introduce something called the product rule, and then I'm going to do a series of problems. I'm going to show you some things about your calculator, and if I have time, I'm going to do the proof. Okay, that's where I'm headed. Everybody okay on that? This is the way that I take the derivative. So, f of x, if I do the first one, well, actually, let me do this one. No, I'll do the first one. It could be viewed like this. Landry, are you okay with that?
Yeah.
Okay. So the rule is this function is made up of two identical functions in this case. One is called x squared plus 5, and the other one is also called x squared plus 5. And what I'm going to do is write the first one down, take the derivative of this, which would be 2x, and write a plus sign. So this is the first function, it's this one. This is the derivative of the second function. Now I'm going to take the derivative of the first function, which is 2x, times the second function. And I'm going to get 2x cubed plus 10x plus 2x cubed plus 10x. And I'm going to get a derivative of 4x, oops, I forgot to write cubed here, 4x cubed plus 20x, which is what we got up here. I'm going to do the next one. I'm going to say f of x is equal to x plus 3 times x plus 4. So I'm going to write down, I'm going to figure out the derivative, and I'm going to write down the first function times the derivative of the second. I'm going to make this a little bit bigger. Is that better? Denise, what's the derivative of x plus 4? 1. Plus, now I'm going to write down, what is the derivative of x plus 3? 1. And I'm going to multiply that by x plus 4. And now I'm going to multiply that out. And I'm going to get x plus 3 plus x plus 4. And we get what Alexis told us it was, 2x plus 7. Now, this is the definition of the product rule. You have a function I'll call h, and it's made up of two functions that are being multiplied together. And so to figure out its derivative, I write down the first, take the derivative of the second, plus the derivative of the first, times the second. Now, Caitlin, this is what I see students do. This is, I'm going to have another sinusoid, wrong. This is what I see students do. They say this. They say this. Well, it would be easy if I just took the derivative of both of them.
Yes.
There you go. Now you can see it. If I take the derivative of both of them and multiply them. It would be easy. I'd agree. Just like when I have this, when I have students do this, and say the answer is this, plus 3. That's easy, isn't it? It's wrong, but it's easy. And this is wrong, because take a look. If I had this, the derivative of x plus 3 is equal to 1, correct? The derivative of x plus 4 is equal to 1. I want an x in here, not 1. So the derivative has got to be 1. Right? Well, it's not 1. It's 2x plus 7. When you do it this way, what is happening is the door that says voodooists enter here start to open up, and you're starting to peek to see what's in there. If you enter, the voodoo bug burrows into your skin and starts heading towards your brain. That's why I'm a voodoo exorcist, and I'm doing voodoo prevention. You got the idea? Don't do it this way. You have to do it the way that I showed you up here. Okay? All right, so let's look at the two ones that I give as examples. Here's one function. It's a quadratic, isn't it? It's in parentheses, isn't it? Here's another function. It's linear, isn't it? It's in parentheses. They're different. So I'm going to figure out g prime of x. Now, Jack is sitting there, and Jack is saying, I'm going to back up. First of all, Jack is saying that's too big. And then Jack is saying, why can't you just multiply those out like we did and then take the derivative? It would be much easier, right? You can. You can. But I'm trying to show you simply an alternative way called the product rule. Does that make sense? So, when you get to a quiz and a test, and I don't specifically say, hey, do it this way, I simply say, find the derivative. You can do it in the easiest way for you as long as you get it right. Does everybody understand that? As long as it is mathematically correct. And if Jack would simply go through and multiply that out and then take the derivative of each individual term, there is nothing wrong with that. Are we okay with that? I'm using this to demonstrate the product rule. So what I'm going to do is I'm going to write down the first function, Jack, which is 2x squared plus 3x. And I'm going to want you to take the derivative of 4x minus 5. What is the derivative of that?
It'd be 4.
4, just 4. So I'm going to multiply that by 4. I'm multiplying this by the derivative of the second function. Plus, now I'm going to write down the derivative of this one right here. This is the first. Jack, what's the derivative of this one?
4x
Plus 3. Though that whole thing is, so it's got to be in parentheses, times the second. Are we doing okay with that? Now I just have algebra. That's the calculus, just that. Now I'm going to do algebra. And I'm going to get 8x squared plus 12x plus 16x squared. I think I get a minus 8x. Does that look correct? Julia's nodding her head in the affirmative. Minus 15. So, Jack, what is 8x squared plus 16x squared? 24x squared. What's 12x take away 8x?
Or 4x.
Minus 15. I'm done. Did I do something wrong, Eden? Okay. Okay. If you guys need for me to pause and do something, okay, everybody's cool, all right? Julia, name one of my functions in here. Name another function that's in here. There's 2 of them, right? So the derivative. What am I going to write down first? Perfect. Times what? I think you said, I forgot my hearing aids. I was already in my truck. I go, do I want to walk in the house and get my hearing aids? I said, nah, I'm beyond that. I can't hear anything. I should have my hearing aids on. That's why I got them. You said minus sine x? Okay, what follows that? Plus what? I got to take the derivative of x squared. 2x. And I already took the derivative of cosine, or you did, right? So your answer is this. I always put -1 is the coefficient. Does everybody understand that? So I write that first. Doing okay? Now, let's say I ask this. I'm going to pause a second. Let's say I ask you this. I'm going to draw this over here. Let's say I say find the point on H where there is a horizontal tangent. In calc, we love horizontal tangents. We love them. They get invited to all our birthday parties. There's a special spot for horizontal tangents. Ryan, how would I solve that?
So, horizontal tangents
Yeah, I went through, I figured out the derivative. Now I got to find the point on this function that has a horizontal tangent.
We set it equal to 0.
What?
We set it equal to 0.
Set this equal to 0. Why 0?
Because horizontal tangent line has a slope of 0.
Horizontal tangent has a slope of 0. Okay, now what are you going to do?
Factor.
Okay, what can you factor out of there?
Negative 2, or I mean negative x.
Negative x. So we got 0 equal to negative x. And that gives me x sine of x minus 2 cosine of x. Correct? Right? Did I do that correctly? So this is nice. This means x equals 0, right? And so I would take that 0, I'd plug it in here, I'd have 0 squared times the cosine of 0, and that would be 0. So I should have a horizontal tangent at the point 0, 0. Correct? What do I do here? Does anybody have an idea what you do there? Don't I have to make that equal to 0? So I got x sine of x minus 2 cosine of x equals 0. How would you solve that? It's hard, isn't it? I'd go to the machine. Speak to me, machine. Go to menu, come over here, go to y equals. Where's my graph? Hit delete because I put that in there, and I'm going to type in x sine of x minus 2 cosine of x. You okay on that, Elijah? You know how to do that? You know what I'm going to do? I'm going to graph this one. Draw. Ooh, I don't like that. I'm going to change my window. And I'm going to go from, well, let's make it 0 to 2 pi. Exit. Draw. There I go. That's better. So if my domain is from 0 to 2 pi, those are my two spots. Would you agree? Right? Now, for the Casio people, will you raise your hand if you're a Casio person? Okay, for a Casio people, you're going to go Shift F5, which is a G solve. You see how it says G solve there? And you must get something that says root. Is that correct, Casio people? So I'm going to choose root. And it's going to tell me that I have 1.0788. Is that an 8? Excuse me, it's a 6. 1.07, if I round, it would be 1.077, correct? That would be my answer. Did I make a mistake?
Mine's not showing.
Other people got something different? Are you in radians or are you in degrees?
I got it.
Did you get it now? Okay. And if you're a Casio person, then all you're going to do is press your right arrow. It's going to jump to the next one. And it's going to tell you that it's 3.643597167. Correct? Casio people, did it work? That's as much work as you want. Casio people, I also want to point out, notice on mine, it says dy dx equals a negative 4.637. Casio people, what is that? It's the derivative. It's the blank of the blank. Blank. It's the slope of the tangent line. It tells you that automatically, isn't that? Does yours say that? Would you like it to say that? You're going to go to Shift, Setup. Do you get something that looks like that? Casio people? And down here it says derivative. Oops. Down here it says, go back up there. Derivative. Just press an F1 and it's on. And it'll do it from then on. Okay. Any questions from the Casio people? Because now I'm going to enter the other form, the TI people. No questions. Okay, TI people. On y equals clear. And what was it again? It was
X sin x
x sine x minus 2 cosine x. And I'm going to change my window from 0 to 2 pi. Oh, I did that wrong. There we go. And so you get a graph that looks like that. Correct? Am I right? So then you go second calc. You go to 0. You go to, let's say I want to figure out this spot here. I'm going to go to the left of that. Press enter, go to the right of it, press enter, enter, and I come up with 1.076874. Does that look correct, TI people? And then to figure out the next one, I gotta go second calc again, pick my 0 as a choice, climb the mountain, slide down the mountain. Press enter, go past the mountain, and then I should come up with the same answer. 3.6435972. Does that sound correct? Everybody got that? Everybody's fine. The people that have the Casio, the people that have a regular TI, and the people that have the enhanced TI. You all know how to do that. I will not tell you again. If you need help, go to the YouTube, type in finding x-intercept on a TI or Casio, and I'll show you how to do that. Got that? All right, I'm going to show you something else. Go back to y equals. I'll start out with clear this, and I'm going to put in x squared. If I graph it, it looks something, oops, I don't want that. I'm going to change my window. Zoom 6. So there's my window. Okay. So what I'm going to do is I'm going to go second quit. I'm going to clear my screen here. Now, on a TI, behave. There you go. On a TI, my favorite button on here is on the left-hand side, third button down, it says math. I believe even the enhanced TIs have that, correct? You press it. And you go straight down to line 8. And you press enter. And it says that. It says N derivative. Enhanced people, yours is something totally different. Yours looks like, let's see if I can show you. I think yours looks like this. And there's a little box here, right? Correct? There's a box here, correct? And then it says x equals box here, correct? All right. Just hold your horses. Okay? So, regular TI people. This means numerical derivative. It's going to give you the number. It's going to give you the actual slope of a tangent line. Let's say we want to figure out the slope of the tangent line on the function y equals x squared, where x equals 3. We should get 6 as an answer. Does everybody see that? I took the derivative, got 2x, took 2 times 3, got 6. That's how quick I did it. So what I'm going to do is I'm going to go to vars, which stands for variables, which is to the left of clear, and I want y variables, and I want to be function, and there's y1, correct? That's where I put the x squared. I press enter. Comma. Then you're taking the derivative with respect to x. That's your input value, correct? So since your input variable is x, you come up here and press x. You will have to do that if you're a TI person every time. Followed by a comma. Then followed by the x value, which I said was 3, that I want to figure out what the derivative is. So I'm going to write parentheses, enter, and I come up with 6. There's the slope of my tangent line. Does that make sense? I also can figure out my y value in case I want to figure out the equation of a tangent line. I would go back to vars, get y1, put parentheses, type in 3 like this, and 3 squared is 9, correct? And I get 9. So my point would be 3 comma 9. The slope of my tangent line is 6. I can now come up with the equation of a tangent line. Does that make sense? Now I did an easy function. You can do that for any function. I can make it as complicated as I want. Does that make sense to everybody? Enhanced. What you're going to do first, I believe you start here. This is where your cursor is blinking. What you do is go to your x variable, type it in, and it'll go in there. Then use your right arrow, and I believe you go here.
It's multiplying by it. There's nothing on top of it.
Let me see yours, because then I'm confused. Yeah, yours is in there. That's exactly what I'm saying. It's blank right now, right?
Yeah, but it's not over the fraction. It's not in the fraction.
It's up here, isn't it?
It's multiplying by it.
No. You're inputting it into the derivative. That does not mean multiplying by. Let me see it again. It's above the fractional bar.
No, it's not. It's next to it.
Yeah, okay. It looks like this. You're right. It's not multiplying either. It's really up on top, but they do it this way. So you got an x right here. And then you got a line right here, and then your thing is right here. What this is, they're really putting it right here. That's what that means. Okay. So then you're going to go to vars, and you get y1. So you go to vars, you go to y values, you go to function, and then you press enter. There should be a y1 right there, correct? No? Allie said yes. Okay. Then over here there's an X. Now if you should be over here now. Am I right? That's where you type in the number 3 and then press enter. And you should get 6 as your answer. Everybody okay? All right. Casio people. Go to menu. Come here. I'm going to clear my screen. Right? So Casio people, if you take a look, I believe you have a button on the top here that says options. Am I correct? Press options. And you get a lower bar like that. Am I correct? Press calc. Do you have that? Okay, now, this is where we're going to change because this is an enhanced Casio. You want to press dy dx. You do not have that, do you? You don't, do you? Yours is like this. I went to options. I went to calc. And I got this. Does it look like that? Ah, you can't even see it. Can you see it now? Does it look like that? Except, okay. So then you're going to go to, you also have a vars button. It's to the right of the option. Do you see that? You're going to press that. And then you have a graph, correct? So you can press that. And then over here you have Y. Did you everybody see that? You're going to hit Y1. And then you're going to press a comma, which is underneath your cosine button. And then you're going to press X. Oh, excuse me, you're not wrong. You're going to put 3 in here. Sorry. And you should get 6 as your answer. Did you?
I got negative 2.5.
You did not get that. Is that correct? You got it now?
No, I got, wait. Yeah, I got negative 2.54. Yeah, I didn't put X. Oh, yeah, yeah, I didn't change the graph. Yeah, now we got 6.
So it wasn't me.
Now.
No.
It was user error.
Yeah, it's the hash.
You make me laugh. Okay, you have that? Everybody got that? All right, I'm going to show you. So everybody knows how to take a derivative now. Plus, I made a video of it, and so it'll be in Schoology and on the YouTube. Everybody got that? Okay, so I'm going to show you something else. So I'm going to go to menu, and I'm going to go to graph, and I got to check my window. I don't like my window. So I got the graph, don't I? Right? Okay, I am going to go to, on a Casio, Shift Sketch. Now, if you notice, it says TANG. Do you see that? That stands for tangent. I'm going to press F2. And it wants to know, where do you want to put the tangent? Oh, let's put it at 3. Enter X value, 3. There's my tangent line. And if I went to Shift G solve, it might tell me well, anyway, it can draw the tangent line for you. Okay? So now, TI people. You gotta turn it on. Okay, hit graph. There it is right there. I'm going to do the same thing. So what you do is, do you see where it says delete stat program? And then in yellow it says draw. So I'm going to press second draw. And there's line 5 says tangent, doesn't it? So I'm going to go to line 5. Press enter, and it wants to know where you want to do the tangent. I'm going to do it at 3. There's my tangent line. Lo and behold, it gives me the equation of the tangent line. 6x minus 9. Back to Casio, people. If you're feeling sad because it didn't give you, tells you 3, 9, you should be able to come up with the equation of the tangent line, right? But you can also do this. Go Shift G solve. Oh, maybe it doesn't. I thought it did that. Oh, maybe I haven't done this. I bet it's not. I don't have my setup done. Okay, I have to exit out of here. I'm sorry. Let me go back to my menu. Let's go to here. Shift setup. And I am going to turn my derivative on. There I go. Now let's go to menu. Now let's go to graph. Now let's draw. Now let's go shift, sketch. Let's draw on the tangent line. Let's put it at 3. There it goes. Now it gives me the slope. It also gives me the slope of the tangent line, right? And it also gives me the equation 6x minus 9. You have to turn your derivative on, okay? So if you go to shift trace, I think it does this. Shift trace. Notice the whole time I'm moving it across, the derivative changes. Do you see that over here? Casio people, that always happens. See how it changes? Or if I wanted to go to a particular number like -1, it jumps there. Not only will I know x and y, I'll also know the slope of the tangent line on any function. Does that make sense? TI people. Let's see what I can do here. Let me hit clear. Let me hit graph again. Okay. To get rid of that tangent line, you got to go second draw and go to clear draw. Did you everybody see what I did? Second draw, clear draw. Then I'm going to hit graph again. And if I trace, I do not believe you can get the slope. You can get the points, but you can't get the slope. Is that making sense? Okay, so TI people, Casio people, you should be able to do this too. And y2, I'm going to draw the derivative. I'm going to draw the derivative. I'm going to graph the derivative. This is how you're going to do it. I'm going to go math. I'm going to go to line 8. Now, for the enhanced ones, you're back to where you were, correct? So I'm going to go to vars. I'm going to get y1. I'm going to put an x in here, comma, and instead of putting a number, I'm going to put an x again. So you enhanced people, you know what it looks like, right? You'll have y1 and you'll have x in those other two spots. I'm going to hit graph. So there's my function, any day now. Right there is what my derivative looks like. So if I go back to y equals, and I make this a negative x squared, and I graph, now that's what its derivative looks like. Are we doing okay? Casio people. I go exit out of here, go to y2, and you're going to go to I'm going to go to options, I'm going to go to calc, I'm going to choose the derivative, so there's the derivative, and then I'm going to go to vars, choose my graph, choose y1, and now I'm going to put a comma, and now I'm going to put x. Does that make sense? And now I'm going to hit draw. Yours goes a little faster, doesn't it? Because you have a superior processor. And then if I hit exit and I come up here and I put a negative in there, draw, there's the derivative. Does that make sense to everybody? Any questions? So, you should be able to figure out the derivative using your calculator of any function, correct? You should be able to graph any function, correct? You should be able to graph its derivative, correct? Even if you know nothing about the function. Everybody okay with that? Okay. So, let's see how good you are. Go to y equals your y1 and put in e to the x. So I'm going to exit here. I'm going to come here, hit delete, and I'm typing in, where's e? Shift e to the x power. So if I leave it like that, what is it going to happen? It's going to back up. Exit, exit, exit. You went too fast. I want you to graph e to the x and its derivative, correct? So when I graph it, it's going to go really fast. There it is. What am I not seeing? Does anybody see two graphs? Why don't you see two graphs? Because they're the same. So the derivative of e to the x has to be what? E to the x. What's the derivative of the derivative? Well, if you have e to the x and its derivative is e to the x, right? You can see that? The derivative of the derivative would be what? And the derivative of that derivative would be what? E to the x. You don't get anything else, do you? It's really the easiest problem. All right. Let's get back to this. Are we doing okay? Okay. Ty, you doing okay? All right. Did I hand you guys assignments out? No. I'm going to stop right now because we're almost done, right?